and he.
Okay, so your support for, this is actually support for 9.5. I think it's actually good to use for 9.4 also, just because it's going over these different exponent rules and negative exponents. Okay, so on number 1, now, couple different ways you can think about this. First thing is, when you are multiplying the same bases, which I am, right? X times X, so the bases are the same. The shortcut or the exponent rule is you add their exponents together. So this would tell me that you do 3 plus -8. You just add the exponents, and what do you get when you add 3 to -8? You would get x to the -5. Now, it's always going to tell you to use positive exponents only. You can't leave in an answer with a negative exponent. So remember, what do you do if you have a negative exponent? How do you fix it? You flip your base. So if my base is a whole number, I need to think of it as over 1 so that I will have something to flip. So if I flip this, what is it going to be if I flip x over 1? 1 over x. What does that do to this exponent? It turns it positive. So 1 over x to the 5th. Number 2. Same thing. I've got x to the -4 times x to the 6 times x to the 8th. So I can add, these are all the same bases, which just means I can add those exponents. So I have -4 plus 6 plus 8. Which gives me x to what? -4 plus 6 is 2. 2 plus 8 is 10. So it didn't end up with a negative exponent that time. Its exponent was positive, which means I don't need to fix anything, right? Number 3. 7y in parentheses squared times 4y in parentheses to the 4th. So first of all, if you have a parentheses with an exponent on top of it, that means everything in that parentheses is, in this case, squared, right? So what is 7 squared?
7y times 7.
Right, 7 times 7, so what does that
14,
give me?
14.
No, times.
Sorry, yeah.
49, right? 7 times itself is 49. Y is also squared, so just write that, y squared. So that turned my 7 squared and my y squared. I need to do the same thing over here. They don't have times. This time, what does that mean? 4 to the 4th power means 4 times 4 times 4 times 4, or just punch that in your calculator, right? Yeah. So just 4, your regular home screen, 4, right? Go up in your exponent with the arrow to the 4th power, enter, which gives you 256. So that raised the 4 to the 4th power. You also need to raise the y to the 4th power. Now I can multiply this. Let's see, 49 times 256. Okay, I'm not going to attempt to do that on my own, right? 49 times 256 gives me 12,544. What are you going to do with these exponents? If I'm multiplying the same bases together, what do I do with the y's exponents? Add them. So y to the 6. Go ahead, go ahead.
Okay, and here you got the parentheses, and then you have one without the parentheses. So it'd be without the parentheses.
Which one?
Um,
Oh, I see what you're saying. Ooh. Without, yes. Yes, okay, I see what you're saying. I didn't even realize that this was multiple choice. Yes, it would definitely be D. Because if you put the B option, shows it like that, right? That would mean everything in here to the 6th power. Well, 12,544 to the 6th power is going to be an astronomical number. Yes, I'm glad you said that. I didn't realize it was multiple choice. So yes, no parentheses. All right, number 4. (26) x to the 8th, b to the 3rd, times -9, x to the 6th, b to the 4th, okay, so I don't have any exponents outside my parentheses, so I don't have that pre-work on this one, right? Because there's nothing up here that tells me I need to raise what's inside here to a certain power. So I can go ahead and just multiply these two terms together. So I've got 26 times -9, which gives me -234. Do your exponent rules. X to the 8th times x to the 6th. Same basis. I'm going to add their exponents. That gives me x to the 14th. And then my b's. B to the 3rd times b to the 4th gives me b to the 7th. Number 5. Okay, so again, no outside exponents, so I don't need to worry about raising what's in here to any certain power. So I just go ahead and straight multiply. -4 times 10 gives me -40. Good. So when I add my exponents, -7 plus -7 is -14. What is your instructions on your answer going to say, though? Do not use a negative exponent in your answer, or however it says it. Use only positive exponents. So who has a negative exponent? Just the x, right? This doesn't, right? If it wanted to raise this to the -14, you would see that, right? The -40 is not being raised to the -14. Only the x is. So the x is the one that needs to be flipped, right? So the -40 stays where it is. If I flip the x, it's just going to put it in the denominator, right? It's going to put it upside down, which makes its exponent what? +14. All right, so remember, I took out 6, so we're going to go to 7. So starting with number 7, here's the rule. When you're multiplying the same exponents, or multiplying, the same bases, you add the exponents, right? When you are dividing the same bases, so if I have x to the 8th over x to the 5th, you subtract their exponents. So you always have to do the top exponent minus the bottom exponent. Okay, so that's the rules. When you're multiplying the same bases, you'll add their exponents exponents, when you're dividing the same bases, you are going to subtract their exponents. So on number 7, you have d to the second over d to the negative 8. Subtract the exponents, right? Because I'm dividing. So I have d. I've got to do the top exponent minus the bottom exponent. So that would be what? 2 minus negative 8. What does this mean, though?
Oh, God.
You're going to add those, actually, right? You're subtracting a negative, which really means 2 plus 8, which gives you 10. So you only ended up adding, though, because why? Because you were subtracting a negative. Number 8, 18, x to the 5th, z to the 5th over negative 6, x squared, z. So I'm dividing, just like always, with fraction. That means you're dividing. 18 divided by negative 6, negative 3. What are you going to do with your exponents? X to the 5th over x to the 2nd. Subtract the top exponent minus the bottom exponent. So what's that going to give you? X to the 3rd. Z to the 5th. This one has an exponent 1, right? So if I subtract those exponents, I get z to the 4th. Okay, let's add one more exponent rule. So if I'm multiplying the same bases, I add exponents. Dividing the same bases means I subtract the exponents. What if you are raising something to more than 1 power? So what is that x being raised to? It's being raised to the 3rd power and the 5th power. Being raised to 2 separate exponents. That is when you multiply the exponents. So anytime you're raising an x or whatever to more than 1 exponent, you're going to multiply the exponents together. So on number 9, I have 2x to the 3rd, y to the 7th. And that is all to the 5th power. So let's see. Each individual thing is being raised to the 5th power. So let's do the 2 first, right? Everything in here is to the 5th. So what does 2 to the 5th power mean? 2 times 2 times 2 times 2 times 2. Or punch that in your calculator. 2 to the 5th power gives you 32. What is the x being raised to? Right. Both of those, right? It's being raised to the 3rd and the 5th, right? Because everybody's being raised to the 5th. The x is being raised to the 3rd and the 5th, so that's right, x to the 15th. And what's the y being raised to? The 7th and 5th, so that's going to be y to the 35th.
Miss Hanson, where 32 come from?
The 2 is being raised to the 5th power. So that.
Oh, okay.
There you go. Yep. All right. 13 and 14. On 13, I have t squared minus 36 over t squared minus 12t plus 36. So, and it says to simplify, and then it has the words by removing factors of 1. Okay, we're just gonna, that means if you are simplifying a fraction and the top and the bottom have multiple terms in them, that means you are going to factor, then cancel. So let me show you what I mean by that. Let's rewrite the numerator and the denominator in their factored form. So let's see. If I'm factoring this numerator, that's it. What are both of those? Perfect squares, right? With a minus in the middle, which means that's a difference of perfect squares kind of factoring. So let's see. What would that be if I'm going to factor
Never t.
t and t for t squared?
Plus or minus 6.
Plus and minus 6, right? 6 and 6 for 36. 1 plus, 1 minus. That's a difference of perfect squares. Now, in the denominator, I've got 3 terms, right? So it's not a difference of squares. Difference of squares only has 2 terms, okay? If you have 3 terms and the first term is just a t squared, it's automatically t and t, right? That's the only way you're going to be able to multiply and get t squared.
So you got to multiply, find a number that multiplies to 36.
So let's see, finding the ways to multiply to 36. There's a lot. So those all multiply to 36. Be careful here. What do you have to add to?
12.
What kind of 12?
Negative.
So which pair looks like it's going to, don't even worry about the negative sign yet. Which pair looks like it's going to make a 12?
6 and 6.
The 6 and 6 pair. Now, if I'm going to make that, if they're going to add to negative 12,
They both need to be negative.
they both need to be negative, which doesn't mess up my positive 36, right? Because what's a negative times a negative? It's positive. So it doesn't mess up that positive 36. So negative 6, negative 6. So there's the factor part. The cancel is if you have a factor in the top that is the same as a factor in the bottom, they can cancel each other out. So this t minus 6 can cancel that one. So what are you left with up top?
T plus 6.
T plus 6 over t minus 6. All right, last one. Z squared minus 5z plus 6 over z squared plus 7z minus 18. Okay, this right here is probably one of the most missed trinomials factoring of all time. Okay, so it starts off the same as the last one, right? Z and z from z squared. You just have to realize what your signs have to be. Okay, so if you're multiplying to equal a positive 6, let's see, 6 times 1 or 3 times 2 will give you positive 6, but also if they're both negative, that'll also, right? Those will also give you positive 6 when you multiply. So now I'm looking for the pair that adds to negative 5, which would be that pair right there, right? So the way that people mess this one up is they say, oh, to get negative 5, I can use a negative 6 and a positive 1, because that does add to negative 5. But what does that multiply to? Negative 6, not positive 6. So just be careful. Your signs have to fit the rules. Okay, so all the ways to multiply to get positive 6. The one pair that also adds to negative 5 is negative 3, negative 2. Doesn't matter where these numbers go. They just have to have the right sign with them.
Mhm.
The bottom one, z and z again for z squared. Let's see, negative 18. So let's see, 18 and negative 1 will give you negative 18, or flip the signs because negative 18 and positive 1 will also. Let's see, the other way, 9 and 2. So 9 and negative 2, or flip the signs, negative 9, positive 2. And what's the last way? 6 and negative 3, or flip the signs, negative 6 and positive 3. So all those multiply to negative 18. I need the pair that gives me positive 7.
9 and negative 7.
That's exactly right. Positive 9, negative 2. It doesn't matter where those numbers go. They just have to have the correct sign with them. So a positive 9 and a negative 2, which means your z minus 2's cancel. So you are just left with z minus 3 over z plus 9. Okay? All right.
Put them in parentheses when we put them on.
You don't need to put them in parentheses. If you would put them in parentheses, if, for instance, you did all this factoring and there was more than a z minus 3 up there, like if there was also a z plus 1 left, then you would have to put, but if it's just one factor, you don't need to put them in parentheses. All right, I will see y'all Wednesday.